important difference. Okay, so this type of transformation is called a dilation. And a dilation is a transformation in which a figure is made larger or smaller. I'm not sure if you can see all of this. There we go. By a scale factor. Remember that from 7th grade? An old blast from the past. So let's look at this initial image, this pre-image, UVW. We're going to write down the coordinates for U is -2, 2. V is -2, -1. W is 1, -1. U prime is -6, +6. V prime is -6, -3. And W prime is 3, -3. So in this case, look at the relationship between the coordinates. -2 to -6, 2 to 6, -2 to -6, -1 to -3. Again, 1 to 3 and -1 to -3. We can see that all of those coordinates were multiplied by 3. So in this case, this triangle was dilated by a scale factor of 3. And remember from 7th grade, we referred to the scale factor as K in an equation. In this case, it says a blank is a dilation where the image is something than the pre-image. So where's the pre-image here? The pre-image is the larger one. So this is called a reduction. A reduction is a dilation when the image is smaller than the pre-image. Let's see how that's different on this side. This dilation, the one that we did on the original one, is called an enlargement, because the image is larger than the pre-image. So before, we were dealing with transformations that were rigid, ones that did not, the size of the shape did not change. Well, a dilation is different. A dilation is kind of like a rubber band. It's non-rigid. It stretches. And so the interesting part about a dilation is that it stretches and it's proportional because the scale factor is the same. So this is the kind of dilation. It says because the two polygons are not congruent because one's larger than the others, we call these similar. And similar is one of those words in the English language that has multiple meanings. We can compare people and say, oh, they have similar personalities or similar outfits. We can compare cars and say that they're similar. But in math, it has a very specific meaning. And in math, similar means it has the same shape, but a different size. And so because the two polygons are similar, a dilation is considered a non-rigid transformation. It's non-rigid. In other words, it stretches or it constricts and gets smaller. It either gets smaller or it gets larger. Okay? So let's look at the algebraic representation. These are enlargement examples. If k, or the scale factor is 2, if the original point is at 3, -7, then the new point will be 6, -14. If we have a scale factor of 3.5, and the original point is 3, -7, then we're going to multiply 3 times 3.5. Well, 3 times 3 is 9, and half of 3 times 1/2 is 1.5. So 9 and 1.5, that makes 10.5. And now you're making me really think. 7 times 3 is 21, and 7 times 5 times 1/2 is 3.5. So 21 and 3.5 is going to give you 24.5. Okay. Here, if we have the original point again is at 3, -7, and we multiply by the scale factor, which is 1/2. Well, half of 3 is 1.5. And half of -7 is -3.5. If we have our original point at 3, -7, and we multiply by a scale factor of 4/10, 3 times 4 is 12, and so it will be 1 2/10. And then -7 times 4 is going to give you -2 8/10. So by the end of this unit, you should be able to describe the properties of a dilation and their effect on congruence and orientation of the figures. So we noticed that they're not congruent. Dilated shapes are not congruent. And let's talk about this orientation for a second. In this case, did the orientation change? So VW is, again, VW is the line segment at the bottom. The hypotenuse of this right triangle is still U prime and W prime, just like the original. So the orientation, or the way the shape is changing, does not change. The orientation stays the same. Okay? Thanks for listening.